Okay, we're going to be working Pathways problem 2.121. This asks us to name a given compound that's sketched out and assign it a molecular weight by summing or adding up all of its parts or component atoms. Start with letter A. Now in the book you'll see that there's a drawing, and it basically asks us to propose a name based on what's shown. And I think for this particular problem, they try to give it a name boron fluoride, which of course is completely wrong for a couple of reasons. It doesn't follow the rules. In addition, this is Br, not borons. This is bromine. All right, so it's the name that it tries to assign is really completely wrong. Hopefully you can recognize that. Okay, but what would the name for this guy be? Well, first off, it's bromine and fluorine. Bromine and fluorine. Two nonmetals, right? So we do not have an ionic compound. We've got what? Binary covalent here between two nonmetals, okay? So what's the rule for binary covalent then? The lower group number goes first. Well, that doesn't help us much here because if you look at the periodic table of the elements, both of these elements are in the halogen column, okay? But the thing is that fluorine's at the top of that halogen column, so it goes last essentially all the time, okay? Remember that was that second rule that we talked about in an earlier problem. So bromine is going to go first. Fluoride is going to go second, okay? I didn't leave myself enough space here, so I need to erase this. Now what's the rule when the first element only has one copy? Usually we want to use mono, right? But for that first element, we typically don't use that, okay? But we do want to specify the number of copies for the fluorine, and it looks like tri would be an appropriate prefix. So we might call this bromine trifluoride. Bromine trifluoride. Now, we want to also figure out what the molecular weight of this stuff is. Now remember, that's pretty easy to do. All we need to do is look at what atoms make it up, add together the parts, sum the parts. That makes a lot of sense, right? The whole is just the sum of the parts in this particular case, all right? So if I'm going to do that, I need to go to my periodic table of the elements, and I find that the atomic weight for bromine is 79.9. I've got one of them, so that's bromine's contribution. I'm also going to have a contribution from the fluorine. Now if I go to the periodic table of the elements, I'll see that the entry for atomic weight's 19 for fluorine. But since I've got 3 copies of that, I've got to add in each copy. Makes sense? So it's pretty simple. Just add up the parts, and if I do that, I get a value of 136.91 for the molecular weight of the compound, bromine trifluoride. So as simple as that, all right? Let's work this next one. Now in the next one we're given a different molecule. It's made up of 1 atom of sulfur and 2 of chlorine. We're asked to assign it a name and calculate its molecular weight. Are we dealing with ionic or covalent? Hopefully, you've recognized this is another binary covalent. Nonmetals bonded together, okay? So we follow the rules for that type of compound. And hopefully you can see how we can quickly assign the name sulfur dichloride as the name for this material. Sulfur comes first because it's in the group to the left of chlorine. Okay, so this comes first, this comes second. We use the di for the chloride. Okay, but we don't need the mono for the sulfur because it's first, right? Now, same thing, molecular weight, right? How do we do that? Well, we add together numbers again. We have chlorine's contribution, we have sulfur's contribution. If we go to the periodic table of the elements, we see that sulfur has an atomic weight of 32.06. It's the number that's in the box on the periodic table. I'm going to write that once since there's one atom in our molecule. There is, however, 2 copies of the chlorine at 35.45. So I'm going to add in 2 copies of the chlorine. If I do the addition, I sum everything up, it looks like the resultant mass comes to 102.96 for that molecule. A little over 100 for the sulfur dichlorine. Right? All right, same thing for the last entry, PCl3. Ionic compound or covalent? I think we say covalent, non-metals, right? So what do we think about naming this one phosphorus trichloride? I think that makes a lot of sense following the nomenclature rules. And if I'm going to come up with a molecular weight, just need to add up the parts, right? So if I look at the phosphorus on the periodic table of elements, it looks like 30.97 is the entry for that. That's phosphorus's contribution to the total. And now I need 3 copies of chlorine, so I'm going to take 3 times the value for chlorine, which is 35.45. On the periodic table of the elements. And if you do the addition, you get 137.32. The molecular weight of that stuff, phosphorus trichloride. All right. Last but not least, there is part D to this problem, which I did not include originally just because I was running out of space when I wrote it up on the board. To give you another structure for a molecule that is essentially N2O5 would be the formula for it, okay, if you wrote it out. So what are we going to call this one? I like the word or the term dinitrogen pentoxide for this one. It's covalent, binary covalent compound. We use di here to denote we have 2, the first element, and pent for the 5 oxygens, okay? The nitrogen, if you look on the periodic table, is one group to the left of the oxygen, so it comes first, hence the dinitrogen pentoxide. Now, if we're going to come up with the molecular weight for this one, we've got to add together the parts again, okay? So it looks like I've got 2 atoms of nitrogen, and I'm going to add that to the oxygen's contribution, which is 5 times molecular weight of oxygen, the atomic weight of oxygen. So this first one, the nitrogen contribution, and the second one is the oxygen contribution. Okay? All we need to do is fill in the numbers from the periodic table. So if I look at the box for nitrogen, see that the atomic mass is 14.01. If I look at the box for oxygen, which is right next door, the book gives a value of 16.00 for oxygen's contribution. So if I sum these all together, I end up getting a molecular weight a little over 108, 108.02 for the dinitrogen pentoxide. All right, so hopefully you have become more familiar with the nomenclature rules and also computing the molecular weights. This skill is also crucial to your success. We're going to see that in the next chapter a lot. You're going to start collecting or computing molecular weights very, very frequently, okay? So that's going to be very, very important. your question might ask you to compute the molecular weight of phosphorus trichloride or sulfur dioxide or something of the sort. You're going to have to be able to do that. So as an integral skill, it's important that you know the nomenclature, how to write the formulas, how to write the chemical equations for these guys, so that you're able to figure out what parts are present, and you can collect them or compute the molecular weights quite easily from that. Okay, very important skill.